All right, so hello and welcome. So today I want to implement pathfinding in my game prototype. So let me first show you around the game prototype itself. Here it is. As you can see, you can click and the hero called Aino will move to the pointed position. Problem is that if I click in this fountain, she will just walk straight into it and just past it like nothing happened. So that's not good, obviously. And that's the goal of today is to implement a pathfinding algorithm, some kind of pathfinding algorithm, so she doesn't walk also in the walls. Um, yeah, and I want to start with this a simple version. So right now here you can see there is some perspective, but at first it, I won't respect the perspective at all. It will just be fully 2D, and I can add that afterward, I believe. And the way it will work, so first I want to try something where I paint the obstacle. So I go to Photoshop or Affinity, and I just paint the zones that are not walkable, or maybe the inverse, I paint the zones that are walkable. To, remains to be seen. And then what I will do is I will send like little collision tests from the feet of the hero to the mouse position and try to find a path between the two. So let's get into it and go to our Finder here, to the project folder. And by the way, this is a custom engine, so I will write all the code in C, and but it should be rather easy to follow. I will explain the steps as I go. And so first, let's go to the background image, open it in the editing software. It takes a while to open sometimes due to a bug. But yeah, basically I will just paint the obstacles as a first step. Oh my god, this bug. All right, so let's go new layer, pixel mods, and okay, we can start painting. So perhaps one approach would be I will paint in black all the obstacles like this. All right, just a rough mask like this. I guess you could go inside here. Of course, I could maybe do a shape. It would be perhaps more efficient, but go with that. All right. And here, like that. Maybe we can work here. Boom, boom. All right. All right. Just a test. Final will be better. And maybe you can also make these obstacles so we can easier test our algorithm later. And now I will export this and call it something like collision or background collision map, or just collision map. It's not really a background anymore. And have it in the games folder, so asset 3 centimeters, and leave it just here, I guess. Collision map. All right. Now, next step would be to get that data into the game, into the code. So let's go. So all of the game is in only one single file currently. You might wonder why, but for now I'm just trying this organization. And I have a system here that allows me to load PNGs. So this will be called collision map. Like this. collision map.png. All right, and I'll just add a struct member here. So the thing to know is that I can now access the collision map from this variable GA, that stands for game assets, arrow, and then collision map. That's a handle to my collision. And here, this function render, it gets run every frame. So for example, if I go, let's say I go just after drawing the background, which is here. So I draw the background every frame, and then if I draw on top of that image GA for game assets, and then collision map, and then I pass the same rectangle as the background. That's the position where I want to draw. And then I pass a color, so white will do, and I save. Then my code gets recompiled, and normally, okay, so this didn't work. So the game tried to reload the code, but it failed. So let's see why. So an assertion hits, I guess when we try to draw the image. Aha, but it's not the same image. What's up with that? So let's see, double prompt. Aha, okay, because I added my my new member in the middle of my struct of game assets. I guess everything, like with the hot reloading, it didn't quite work, probably, and the collision map took the place of the background light, that took the place of the foreground, etc. I suppose, not sure. So let's see if I run it again. Does it work? No, it doesn't work. Okay. Because the file collision map is not found. What did I misspell it perhaps? Collision map. Okay, so I saved, I guess I saved it the wrong place. No, it's here. It's here. Collision map. Let me see. Collision map. Okay, I just don't know how to write. Okay, let's try again. All right. Okay, so we got our map loading in the game and drawing on top of the background. So obviously the goal is not to draw it, this collision map. The goal is just to sample it at certain positions to know if we hit an obstacle or not. So what I will do is I will go to my render function again, go after that drawing of the background and the collision map, and I will draw a circle at the mouse position and try to change its color when we are hitting something in the collision map. So draw circle, and then the position will be get mouse pose or mouse position. Okay, mouse pose. And the radius, let's put 20, and the color will be green when you don't hit anything. All right, so we already have a small issue, which is that the circle is not placed in the correct space. You can see it's offset from my mouse, and that's normal. It's because I put that in world space, right? So if I put my mouse at coordinates 0, 0 or near 0, 0 in the window, then on the circle will appear in coordinates near 0, 0 at the top left of the world. But when the camera scrolls, the circle doesn't match. So I have some coordinate space going on here. And how it works is I push some transforms. So let me see if I can find it. Where is it? Select destination, no. Okay, so just right now I'm a bit lost, but or translation, translates, push. Okay, it's here. All right, yes, okay. Okay, I see. So I drew my circle, but after I push the translation, so effectively I mean word space if you're used to things like Unity. So I want to do that before I push my scale and translation. So here, now it should follow the mouse, and it doesn't. It doesn't, which is a bit annoying. Am I pushing something else? Scale. Yes, I'm pushing the scale here. Okay. Okay, it's a bit messy. Probably I should clean up a bit my code, or maybe there was a reason, but I don't know. And now, okay, now the circle is drawing. It's just behind everything, of course. So maybe actually what I want to do is not draw in screen space. I want to draw it in world space, actually, because I want to go somewhere in the world. So it was not that stupid to put it after drawing the collision map. Just I need to transform my mouse position. So I don't know why I didn't think of this earlier, but transform. So point to screen or screen point to local. So that's what we want. We want screen point to local. Local meaning the current transformation of the world, I guess. Maybe I should look into my naming. But here you can see we are just doing exactly the same actually here when we select the destination. So when we click somewhere to go in the world. So here, for example, this is the code that selects the destination. So if we transform the mouse, now we should be able to, I should save. And now, okay, now we have finally a circle in quote-unquote world space, and that's nice. Now, what I want to do is check whether or not that world position, is overlapping our image or our collision map or not. Like if the collision map has a transparent pixel, which would mean it's free to go, or if it has a black pixel or opaque pixel, which would mean that you cannot go there. So let's do just that. So let's put our position in a variable. Target pose. Target pose, and let's put it through. Let's see. So we want to access our collision map. So to do that, you must do get image. I believe it doesn't have the prefix that everything else has yet because it's not final. I tried to develop it in that way that I don't put the prefix until I don't know, I put stuff in temporary files and then I bring them in the final API when I am happy. And in this case, it's pretty recent. So image call map. Okay, call map. And here we can access the pixels. So the pixel of the collision map. And right now it saved that RGBA image, and it's compressed as a PNG, but when it's loaded, it gets uncompressed, and it's just stored with 1 byte per channel and pixel. So since we have 4 channels, it means we should go in steps of 4. So we can already type 4, and then so we need to find the coordinates on that collision map, and the map is what's the dimension? It's okay. So it's in height. It's double of 1080 pixels, And in width, I don't exactly know, but we can access that data on the image itself, as you maybe saw the autocomplete show map. So size pixel X, for example, is the width, and size pixel Y is the height. And the thing is that when I import that map, I do some stuff on it, like I resize it, so by half and stuff, so the sizes will be probably different than the source image, the PNG. So we can have a look if we log the sizes. So collision map size, and let's log it as a vector. So I have something called vector2 string, I believe. Yeah, and it's even a vector2 integer. That's perfect. That's exactly what we have here. Loop. And let's see what it says in the console. Nothing. All right. Okay, I have to focus the window. I forgot that if you don't focus the window, it's paused, just to save some power. And yeah, we see that the height is this, the width is this. That sounds good. The resizing worked. That's nice. And now what we need to do is take the coordinates in workspace, which should be, let's see. So transfer screen point to local. So let's log also our target position. And instead of logging it, we can call a function called track here, a little utility function that I made. And it should show the target position in the top left. So right now we can check the values of our target position live, which is pretty handy instead of polluting the logs like this. So here we are at 0, 0, then we go down and we arrive at 1080 pixels. That makes sense. And then the x-axis goes positive to the right. So positive to the downwards and positive to the right. So now we should try to map those coordinates to a pixel in the collision map. So how do we do that? First of all, I want to convert this pair of floats, this vector2 of floats to integers. So let's do that. Maybe you can already do it at that stage. So vec2, what's this? Yes, perfect. I forgot that I had this utility method or function that will just floor both components and return an integer vector2. Okay, and let's adapt this one. We pass it to the tracking thing. And now, of course, we have this one that expected the floats vector. So that's okay. We can just convert it back. Anyway, it's just temporary. And yeah, the track thing cannot track a vector2 int right now. Maybe we can just modify it real quick. So this is some macro trickery that allows us. Oh no, it's so ugly. I will do it later. It's the rest of the code is too ugly. I remember now. So we really don't need it right now. We can just track maybe. We can just track the x and y position separately. That's fine. Okay. Okay. So now we have integers. Great. Now we want to try to find the index of the pixel. So pixel index, I will say. So if you think about it, the index of the pixel is the position in the x-axis. Like imagine I'm in the first row, so it's just straight up the position in the x-axis. And then we want to add as many pixels as needed, as many whole rows of pixels as we are in the position y. So basically, the way to get the coordinate is to do target pose x plus target pose y times the width of the image. So call map width, not width, size pixel x. I do that because then I confuse less often width and height with just x and y. I find it easier. So now I get a pixel index. I should probably check that I'm in the bounds of the image, otherwise this calculation will be wrong. But for now, I'm a bit lazy. So let's just check that our index is correct. So that's no pixel index, all right. And it seems reasonable. Like if I go down, I guess at each row of pixel I increment by the width of the image. So yeah, that seems to work. And then if I go close to 0 in y and go right, the increment slowly. It's hard for me to be precise, but you get the idea. So we can use that pixel index just to index into the collision map pixels. So I go this way, pixels, I go pixel index, then times the number of components of the image. I happen to know that the image has 4 components, so 4 bytes per pixel. But what I could do actually is take it from why not from the image itself. So it will, if we switch to one channel only, which makes sense, we will do that later, then it will adapt, the code will adapt by itself. And then I want to take the alpha, and the alpha is always in this engine the 4th component, so I can just do +3, because +0 would mean the first component, +1 the second, and +2 the third, +3 the 4th, so that's alpha. And float alpha. And let's track it as well, just because we go really step by step, break it down, and check all the steps. We might not need to do that always, but okay. So 255, so the maximum value for a single byte, and yes, it works. So here I'm at 0. Here I'm at 225, 255. Perfect, perfect. That's already great. I think I can go in the editor as well, and it works just as well. Perfect, perfect, great. So let's remove those. We don't need them anymore. This as well, and let's change the color of the circle depending on the alpha. And let's define also some kind of threshold. So let's say heat, and is a heat a good variable name? I'm not sure. Maybe I prefer, no, okay, heat is fine. And if the alpha is bigger than, let's say 100, then heat will be true, otherwise it will be false. And then we can use that heat value here with a ternary operation like this. And so if we hit something, we want to color the circle in red. Otherwise, we want to color it in green. Okay, let's see what it does. Yes, perfect. Okay, so now we have a change of color when we hover over not transparent or opaque pixels. Perfect. So we could already do a test to check. Yeah, we could already do, like, this is the code to select the destination. We could already add, if we don't hit, so probably I should change at some point the name of the variables to be more precise, but if we don't hit, if the mouse is not over something, we can select the destination. Otherwise, we don't go here. So this works. this doesn't. So already we prevent the problem of going straight into a building. So let's maybe, I have an idea, maybe I will make the color of the heat map, not heat map, collision map, a bit darker. So so this is RGB A, so A will be very low, and now we just have some kind of shadow where the hits are, and maybe we can even tint it in red. I guess with where is the color overlay? Check. All right, perfect. And save flattens. Okay. And if I refresh, yes. What the hell? Okay, so I didn't expect the background to become this color. So I guess something is wrong with my PNG. I'm a bit surprised right now. What if I go back to this? Strange. So it's not transparent anymore. I cannot see the ground anymore. And I don't know why. So maybe I go back to this. I overwrote the background itself. Okay, that's pretty stupid. So last time when I exported the map, I went here and then export. And no, not this. Collision map. Where is collision map? Here. Oop. And now I replace it, and I guess it will show up again in transparent. So that's why we just have a little hint of red. Now I should restore the background that I overwrote by mistake, which is here. Okay, I can discard the change. So this is the old and this is the new. Refresh, and here we go. So now we have a slight red tint where we can't go. And our code is working. That's great. We cannot go in the fountain anymore, except if we cheat a little bit and click here, and she will happily go through the fountain. So maybe actually this is not that much of an issue, because the game is meant to be played on a phone, and on a phone you won't be able to click the other side of the fountain. So maybe that's fine. You could still do stuff like, oh, is that a crash? Oh no, I just clicked outside of the window, I guess. No, this is a crash. Okay. What happens? Of course. Okay, I just clicked, I guess, outside of the image. So it tried to index into the pixels, but further than the last pixel, which caused a segmentation fault. By the way, normally I should get a goal stack, a stack trace, I mean. Here I disabled it because I had some problems, but I should go back to fix that sometime. So let's just clamp. I'm pretty sure this is the issue. So let's just clamp the pixel index for now. Or actually, let's clamp the coordinates. Clamp integer. So we want to clamp this minimum value inclusive and maximum value inclusive. Okay, so maximum value would be the call map size x. Okay, so we clamp the x coordinates, and it should be it's inclusive. So we don't want to. We should basically go -1 to not have a out of off by 1 error. Sorry. So now the other sides, the y coordinates. All right. So here it's easy. I just have to replace x by y and run it again. All right. So now we have another issue. Let me see. Expression. So okay, here you can see the code stack I was talking about. Pretty handy. should make it work with the segfaults again soon. So what's going on? Collision map. What? So collision map is here. I do not understand right now why it doesn't work. Okay, let's try again. Nope. Let's run it in the debugger then. I have to think a bit, but it's hard. I'm a bit tired. So when we try to draw the collision map, we get an assertion, and the assertion is in this function, which is supposed to just give us a pointer to the image that we want to draw. And this means that, so there is a global array of images, and this means that the index of the handle we pass in is bigger than the size of the image array. Basically, we try to access an invalid handle. And why is that? Get image pointer. And what's the value of the handle? The value of the handle is index. Oh my god. Index 12, type 1. Type 1 means an image. Index 12 seems out of bounds for some reason. Okay, I get it. Okay. So this is consequences of some changes I did recently with the asset system. So bear with me, I will just fix that really quick, and I won't explain everything yet, but basically right now there is a one function asset import that runs when assets needs to be imported. They are cached, so it will run only once per asset. But right now I need to explicitly say I want to keep this asset loaded from my game. Okay, so I need to say load image and then collision map. And the reason it worked before, I guess, is that because it was imported, then it got cached, and so the second time I launched the game, since it was cached, it didn't import it, so it didn't load it, and so this is a limitation of my system right now, but I'll fix it later. Okay, so now it works again. I cannot go in the walls where I can walk everywhere else, and I can go through this. And now we want to fix this. We want to do it so the hero checks wherever she goes. And the first step to do that is to draw to do some testing in front of her feet, right? So maybe what I want to do first is draw a line from her feet to the target position and do some tests along the line, to see if I hit something or not. So let's go in the code again and let's go to target. I don't remember what was the so render function and then set destination. Okay, and our circle is here. Okay, so we get the target pose. Maybe I should say mouse pose. Yes, and we will draw a line. Just draw a line for now. Draw a line up from the position of the hero, and first of all we should get that hero. So here we have some code to get the hero. Should I move it up or should I go? Yeah, maybe I move it up. maybe I move it up for now. So like this, and this is two as finding experiments. Okay, and the position of the hero is hero arrow. You see it coming pose, and we want to draw a line to the mouse pose. Like this. Okay. Okay. Give some width to the line and give a color red. All right. What's wrong? Okay, this is not a float position, it's an integer position, so we here again have to convert it to a float position. Perhaps, yeah, perhaps I should do that, not to string to vec2. Okay. Okay, so now we get a line. Perfect. And now what we want to do is test along that line. So how far? So I guess I will start by testing at a fixed distance. Yeah, let's do that. Let's test at a fixed distance. So we need to do some geometry. We have the start position, we have the end position. So how do we do that? We can, if we wanted to test in the middle, would be easy. Test pose. We would, and let's replace here, test pose. To test in the middle, we will just lerp between the two, and lerp at 0.5%. So basically we do the average of two positions, and the two positions are of course the hero's position and the mouse position. And the mouse position is starting to annoy me that I have to convert it every time, so I think I will take this out and go vec2 I mouse chords, and this is a vector, and here I can just round it here, I guess. Floor to int, because we want to floor it to the pixel it's hovering. Okay, I think that should be fine. And the mouse chords, we don't need it. Okay, because I just hard-coded it, inlined it here. Okay, and this we can get rid of. And okay. So this, in theory, oh yeah, I cannot lerp like this because this expects floats, but I have vectors too of floats, so vectors in 2 dimensions. So lerp, vec2 lerp, perfect. And the test pose is now in the middle between our mouse and our hero. And you can see the test is still happening at the mouse position, so I guess test pose. So yeah, let's get that down. Let's put that all in a nice, neat little block. And this is testing. And the position will be this one. All right. Nope. Test pose. Okay, we have a compilation error, of course. That hit variable needs to be accessed from the outside. So I regret my block, but okay. Let's say do it like this. Okay. And now we want not to be in the middle of the line, we just want to to test at a fixed distance, because what we will do is we will test it in steps towards the mouse cursor. And if at any point we hit something, we will have to find another route. So that's the concept of pathfinding, right? So what I want first is to put my circle at like something like 50 centimeters in front of her. So let's go, and that's just a visual unit, like estimated units, but of course it's pixels or coordinates, abstract coordinates in the program. So instead of doing my lerp and looking at where did I do my lerp? Here. I want to measure the distance between those 2 points and then find the factor that I should put here depending on that. So float list to dest. This distance to destination. And I think we have a distance, yes, vector to distance, and we give it the hero's position as well as the mouse position. That should give us the distance between the 2 points that we can use here as a divisor, I guess. And then if we say 50 pixels, perfect. So here we have 50, it's not pixels at all, it's just units. So 50 units, and then, yes, that's exactly what I wanted. Okay, so if we are just at the edge like this, here she knows that she cannot go here. That's nice. She cannot go here. Even if my mouse is further along, she knows she cannot cross. So if she's here and I tell her to go here, she knows she cannot go. All right, perfect. Perfect. So now the next step is to make this sort of recursive, right? So if I go like here, I know I can go here. Now I want to do the same thing all over again and test here, and then test here, and then test here, up until the last point. So should I do a function yet? Probably, maybe. Or should I do a loop? Really doesn't really matter that much, but let's do a loop for now. So while true, I like to start with, I like infinite loops. That's my dirty secret. I love infinite loops. So let's draw a circle at the tested position, and instead of hero pose and mouse pose, I want 2 variables that could be considered parameters if we do a function later on. So start pose and end pose, and we want to initialize those with the mouse pose and sorry, the entity, so the hero's pose, of course, and the mouse pose, which is the target, the end target. And let's replace, so start pose, and end pose will be mouse pose. And perhaps we want to draw. So this is the real test position. Maybe we want to draw the line only between the start pose and the test pose, and then draw the circle here at the test pose. Sounds good to me. And then at the end of the loop, we want to replace the start pose with the test pose, right? Because we want to start again, but this time from the last test position and move towards the target. So if I save this, I guess this will be an infinite loop since I didn't specify any exit condition. So that's my bad. So this will crash if it hasn't already. But of course, if the start pose is equal to the end pose, or if they are close, so distance. By the way, we could do it in the while condition here. So distance 2, and we can take the square distance. We don't really care. We want to check if they are almost equal, because of floating points in precision, it's best to check if they are almost equal. So the square position, the square distance is faster to compute than the distance. So we use this. If the distance is smaller than, let's say, 1, we are fine and we can exit the loop. Okay, so we didn't crash, that's nice. But we don't draw anything anymore, which sucks. So start pose, end pose, they are not the same, so they should be bigger than 1. Start pose, test pose. So let's see if we get, let's just track show on the screen this condition, and let's see if we are actually. Okay, so this is the distance from the hero to the mouse. It seems high to me. It's the distance squared. Yes, already forgot about that. So we are going into the loop. Oh, it's if it's bigger than 1. Okay, if it's bigger than 1, of course we want to stay in the loop if it's bigger than 1, the distance. I was thinking about it in the wrong way. Okay, infinite loop. Shit. Okay. So what's wrong here? So first of all, I will kill this. Okay. What's wrong? So my start position is overwritten by my test position. Let's see if I put something like 100 here. Now we have something showing on the screen, interestingly enough. So this managed to work. And the screen is dim because there is a transition at the start. So we probably got only one frame of the game running, and now we are stuck in an infinite loop. But the frame 1 seems to have succeeded, and it went from here, and notice there is some collision here, but arrived at the, oh, of course, I'm pretty dumb. Of course, if I overshoot in my lerp here, so I have the distance to the destination, which I use to divide the distance I want to lerp. So start position and position, and I want to find the percentage of that I should pass to the lerp to advance a fixed distance, which is 50. If we are almost at the destination, we will overshoot. We will go higher than 1 here and overshoot our destination. So I should clamp this as well. So clamp, and I clamp it from 0 to 1. Or I could use a maximum, I guess, or a minimum, but I prefer the clamp. And here, in all its glory, perfect. Yeah, that's exactly what I want. Great. Okay, that's pretty good. That's pretty good in my opinion. Okay. So now we want, there is no point in, look at that. There is no point in continuing when we hit something. We don't want to continue from that point, we want to go back to the previous point and then expand our search in other directions. So if we hit the bank here, the bank, after that first red point, we want to go back to the green point and then go up or down. Here the solution will be up. I happen to know that, but the algorithm might not, so we will test both and take the best, I guess, or just take the first that doesn't hit. And for that, we will need something recursive. I think it will be way easier. So I will do a function. And by now, we know that we do this function, we want a start position, an end position, I suppose. Yeah, I guess, yeah, let's start with that. So here, maybe I can split my screen. It right. Okay, so that will be the usage pathfinding experiment, and this will be the function. So pass find step, and we will need to pass some more data, but for now it will just be the start pose and end pose. So okay. Okay, what do we want to do in there? We want to take all of this, or I guess, yeah, we can call pathfind step. We can do it outside of the loop now. We will use recursion, and start pose will be hero pose, end pose will be mouse pose, mouse pose. Can get rid of this, and basically we do this. Just take all that logic and let's see. So we get the distance, we get the test position, draw a line to it, we test that position. If we have a hit, we draw a red circle, otherwise a green circle. Now, if we get a hit, we want to go back. So I guess we can return to go back one step, literally back one step in the stack, the call stack. And we should return that we hit something. So we should return hits. That way, wait a minute, if we don't hit something, we can go ahead and call the function again, right? Maybe let's start with this. I'm not too sure yet. I'm thinking a bit slow because streaming, but let's go step by step. So if we don't hit, we want to call it again, right? And we want to call it again with the start pose being the current test pose, because we know this position is free, so we just want to continue from there, and the end pose will stay the same. That should still work, I suppose. We should check that our test pose is not at the end, because if it's at the end, so if test pose, so that will be the check that we did here. So maybe we could say arrived. If we arrived, which means we are very close to the end point, let's say 20 units. If we arrived, we want to return. Otherwise, we want to continue. And okay, we got a couple of errors. So of course, our hit is not declared anymore. Our call map. Let's pass it. could make it global or something, but but it is global actually. It is global. It is in the assets, so I could just get it again. Image call map GA for game assets and collision map and get image. All right. And this should be very, very fast. It's just indexing in an array of images, so no problem there. This is not a pointer. Okay. And here what's wrong? This pose if arrives. Arrived. Okay, going quite slow, but we are getting to it. So if we arrive, we just want to return. Otherwise, we want to continue. And if we hit something, we also want to return, right? So maybe let's not have a double negation. Let's just do it in the natural order. So if we hit something, we want to return false, let's say. Speaking of double negations, let's return whether or not we hit something, not whether or not we don't hit something. So let's return false here. Yeah, false because we didn't hit something and we arrived. We need some way to different. Oh no, that's fine because we just code here. Okay, so if we return false, that means we arrived. If we return true, that means we hit something, which might not make that much sense, but let's go with that. Okay. I think we are all set. Let's say then hit here equals pathfinding step, and we just have to we already plugged the arguments here, so okay. And the map here is not used anymore. All right. Another problem. So I guess I don't return always. Oh yeah. What happens if I? Okay, so I continue pathfinding. I go to the next step, and then I should return whether or not. I guess. Yeah, I should just return the result of the next step. Okay, let's. Okay. Good. So now it stops. Now it stops when it hits something, which is nice. So it's progress, slow progress, but progress. Okay. What would be the next step? The next step would be to go back one step and continue at another direction. So if you hit something, you return true currently. Meaning here, we should pick another direction. And I'm wondering how I could do it best. So one way I could do it is put a for loop here and retry at different direction, different end positions. But yeah, that sucks a bit. Maybe I should rather do it here, because if I hit something, I want to try right away, like with the same start pose, but a different end pose or a different test pose, let's say. So yeah, I should really have my loop here, in here. Doesn't make sense to have it elsewhere, so that's okay. That's good. The distance to destination will always stay the same. I could do it multiple ways. I guess I could just rotate the test vector a little bit. Let's go into a drawing app just to prototype a bit the algorithm. So thank you. You get hit, you get a hit here. Let's say the geometry is like here, Oopla. Here, and okay, so no hit, no hit, no hit, hit. Now you want to look maybe here because like you have some kind of. I'm imagining that the step distance is proportional to the size the character takes because I want to, like, let's say the character has some width. I want to check that this line is continuous. Yeah, it doesn't really make that much sense. But I'm thinking maybe the next point should be in a triangle that has the same distance here, here, and here. We should like try here. So maybe we could do some geometry to get to that. Yeah, or we could just rotate, I guess, this vector. This vector, just rotate it some amount of degrees and try again here. And also rotate it here and try again here. So maybe pick a direction random and then try here, then try here, then try here, then try here, then here, etc. And then if we find no outcome, we go back to this one. That will be like for the next step, but that's basically A star pathfinding, where we go back to our previous best option and search from there. So, so what would be the best way? Because to be honest, I don't even know how to rotate my vector right now. Okay, so let's try this triangle idea. How would I get that? So we have the coordinates of this, the coordinates of this. I want to get this, and we have the length of all of those. Yeah, I guess I have to write some way to rotate with trigonometry. So this rotates the drawing context, so that's not what we want with the matrices. I don't want to go full matrices, of course. I just want to rotate. So we could say test pose equal test pose. Well, first of all, we need to get that vector, right? We need the vector between start pose and end pose that goes just the length that we want. So I guess an easy way to do that with what we have right now is to get the difference between two sub the difference between start pose and test pose. And I guess that's more like test pose minus start pose, and then we get the delta. And the delta we want to rotate that. So rotate a point around the origin is not too hard. I just have to look it up each time because I don't really integrate that stuff yet. So rotate a point into the rotation about points. Yeah, sure. So it will tell us to translate to the origin and then do. Imagine the points. If you wanted to rotate the point around the origin, the coordinates of the point will be located. Alright. Alright. Yes. This is quite the classic way to rotate. So delta, the rotated delta, let's call it like this. Delta would be vector 2, and the first coordinate will be x prime here. So x times cos of the angle. So x delta x times the cos of the angle, and then the other coordinates, the y, then minus y times the sinus of the angle, alright, and the other coordinates, I can use the same template, but it's y times the cosinus and x times plus x times the sinus, okay, and it's y, and of course I forgot here to put delta and delta. Okay. And I should define my angle, and it's in radians, I suppose. So, I mean, I'm sure. So I could use pi. Do I have a pi? Pi times, or divided by 4, which will give me a 45-degree angle, I believe. And that rotated delta, I want to draw it, just to see what we are doing. So I will draw another line, maybe in blue, and it will go from the start pose to the start pose plus the rotated delta. And we cannot do that, we are in C, so vec2 add, and we add our start pose with the rotated delta, and go back to, yes, sweet. So now we have rotated blue vector, rotated by 45 degrees, great, amazing. And so of course, if we go the other way, if we put a negative angle, it will go the other way. So now let's put all of this in a loop. My plan is to do that if you hit something, here, we want to try again with some other angle, right? So we start with an angle of 0. This will be angle increment, and this will be angle. And we start at 0. This is a constant value. We can, and so if we start at 0, I guess this should be in a for loop or while loop, while angle smaller than pi. So if the angle is bigger than pi, then we have done a half turn, and it doesn't make sense to go higher than pi. And we want to draw the circle, we want to draw everything, and if we do not hit, we also want to break, right? If we do not hit, we have found something, so we stop. So if we do not hit, we want to break. I guess it's not quite true. Actually, I want to put all of this as well in the loop. So if we hit something, we want to just continue the loop, right? If we don't hit something, we want to check if we arrived. If we arrive, we return false, sure, because we didn't hit something, I guess. And yeah, if we didn't hit, we want to continue the pathfinding to the next step, so that's good. And test pause, why isn't it happy? Okay, now it's happy, I just had to save. And so if we did hit something, we just want to go back to the top of that loop, pick another angle, important, so angle plus equal angle increments, and do it all over again. And if we happen to go further than this, it means then that we made more than a half turn. So maybe actually we want to say maybe if we go more than by I'm doing some weird stuff here, but yeah, just give some margin, you know, because yes, so it stops before it goes back, because it would be weird if it went back. All right, so we turn now, and here if we go out of the loop, that means we tested all the rotations and we return true, meaning we should keep searching, right? I guess we'll see later. So this might end up in an infinite loop. Indeed. But I'm not sure why exactly. So yeah, this is not the best code, to be honest. Not sure. Let's try in the debugger. Oh, maybe it's the previous version of the code that got stuck. No. Okay, so pause. Let's see where we are. Print. Let's go to one pin. I don't need two pins. We are here. And what's the depth of the call stack? Okay. What? Yeah, I don't need to log this. This is just noise. Let's save, compile, run again. Oh my god, yeah, okay. So we are here. What? I need to go out. Internal debug error. What the hell? Guess I have. Whoa, it worked for a few frames. I suppose. I return true only here. What do I do with the return of this? I return it immediately. Yeah, okay. If the return of this is true, that means we couldn't find a way, and then we should stop. So return true as well. Return true. else. I don't know what I'm doing. A bit. Try again. Okay, infinite loop. Maybe we can just return in any case. Just to get to a place where we can test. Nope. Ah. Just skip this. Again. Am I stuck in one of the loops or? So the angle is incremented here each time. We don't have a Stack Overflow, so I guess it's not infinitely recursive. Maybe it's going back and forth. The angle is incremented every time. So this eventually goes over this, and it should get out of this. So I do not understand why we have an infinite loop. It compiles fine. Okay, maybe to see it more clearly, we can have some kind of safeguard. Static int safe tests count confa like this, test counts, and we increment that each time we do a test. So I guess here, and if test counts is bigger than 100 or 20, we return. True, false, doesn't really matter, we don't use the return. And this is static, and we have to reset that, otherwise it will run only one frame. And we do that here. That way I make sure that my loop will always exit. And I hope, yeah, okay. So now we can see something at least. Good, good. That's progress. So if we overlap, something interesting, so it's proportional. Yeah, my rotated vectors go proportionally. Makes sense. And why were we in a loop? So I can see the lines are they seem a bit thick, right? So I suppose it goes over mm, um, rotated delta, maybe. Yeah, I don't understand. Right? Oh, okay, that's very stupid. I showed before that I could go the other way by putting a minus, but now, of course, this condition is never met. Okay, all right. Oh, and also, right now I don't test using the rotated delta, so that's also pretty dumb. So this is the test position I want. Now, this is the test position I want, and so I guess I can just overwrite test pose with this app. Now we're talking. Now we're talking. Yeah. Okay, so you can see when it doesn't find. Hmm, that was not intended, this effect, but it's cool. Don't understand it. It tries to aim for my cursor at every step of the way. Okay, I see. Let's make it so we can move, because that was useful to test stuff. So hits. Let's just remove that check for now. So now we can, yes. No, but it's, yeah, look at that. Pathfinding, yeah. Yeah, all right. We are starting to get somewhere. Of course, now that I see that, I realize that we should, the path to the obstacle should be more straight, you know, it should go here and then like straight here and then straight back, which we can figure out later. Like we can go walk backward basically and try to straighten the path, I suppose. Mm, nice, nice, nice. I mean, it's already kind of functional. Like we just need to make it search both sides, and it will already be technically a pathfinding algorithm, right? So now, um, let's see. So now what I want to do, it will be quick to make it search both sides. I just have to switch the sign of the angle each time. So let's say, and actually let's say if the angle is positive, then I want to switch the sign of the angle. No, I want to switch the side of the sign of the angle anyway, always. But if the angle is positive, I want to increment it as well. And the first time we go, the angle is 0, right? So the first time we go, we want to increment. So let's say if it's equal or bigger than 0, we increment. And we can do it before the, if it's bigger or equal than 0, we increment. Yes, yes, that's quite cool. I like it. Oh, it goes below. Doesn't quite reach my pointer. I guess it's because of the safeguard. So let's remove the safeguard. Safeguard. I didn't call it, I call it hit test or count. Or, test count. Test count. Yes. And let's put it at a very high number so we never get stuck in a loop. Oh, wow. What the hell happened here? Let's try again. Okay, let's put the safeguard back. Okay, so maybe, I suppose so many circles were drawn. That's the, okay, sounds Okay, so my headphones are low on power, so running into some issues, but I'm charging one while using the other. Okay, so let's go back to it. I'll check from time to time that the sound is going. Okay, so I was saying that probably the assertion that we hit is because there were so many circles and lines drawn that the graphic buffers were overflown or overflowed. Nice. But it's trying its best. It's trying to find a path. The reason it's not working, well, first of all, it's impossible to reach this point, but it's trying like to pick some angles and then go back. It's trying to go back, so we should prevent that somehow. Well, I think it's already cool. So right now, of course, it doesn't follow the path. Why? We have an issue here. Don't fully understand now. Okay, we will use the test count safeguards to our advantage and stop after test count. This variable, static variable, we will increment it with the mouse wheel. And that way we will be able to visually progress through the tests. Let me see. So we call our pathfinding test here, okay? And just before, we will increment our stop after test count value, depending on the scroll wheel. Scroll delta, if y is bigger than 0, we increment. If y is smaller than 0, we decrement. And let me track this. Okay, so now we stop after 10 steps, right? But if I move the wheel, I can change when we stop, so we can see how the algorithm progresses, which is pretty cool in my opinion. I will just reverse the direction because it feels more intuitive the other way to me using it. Yes, perfect. And I could maybe clamp it, but no, okay. Yeah, it's not bad. Not great, but not bad. Can it go all around the fountain? Let's see. No. Ah, I have to increase my test count. Yes, it can. It can go all around the fountain. That's nice. So we should really have some way to make the path to the obstacle more direct, you know. Should I work on that next? Or maybe what I can do to have an immediate result, and maybe I stop the stream after that, is I test first the mouse, and if I get a hit, I don't allow any movement for the hero for I know, because it doesn't make sense to try to go somewhere where you know is not reachable. like the destination is not even walkable. And then for other destinations, I go toward the first test, the first valid test, or maybe I could brute force it and go towards, yeah, if you think about it, I could totally brute force it and pick, well, okay, let's do the first thing I said. So first we want to return whether or not, or maybe we just want to do a first test separately. So let's factor the testing out. Let's factor the testing out. Testing a position. So I guess hit will be equal to hit pose call test at a position, and the position will be called test pose, and I take all this and make a function called call test, and that returns a bool call test, and that takes in a test pose. Okay, and I return that hit value hit. That way I can use that call test. So let's first check if that works still. So no, because we don't have the color region map that we can get right here. Okay, it compiles and it still works, so that's not a surprise. It's basically the same code, just with a function. And this is inside this is, where is the, yeah, okay, pathfinding experiment. This is in the render function. So we just want to know this is free. Call test and mouse pose. So we just want to do a quick check of the destination, just the destination, to know if we have a hit or not. And here I just reversed the meaning of the variable dest is free. And if it's free, it means we can look for a proper path. And I guess we could return, instead of a bool here, we could return the destination of this step. Wonder if that's a good idea, but I will do it for now. Vector 2 and so if we don't hit, we try again, or we continue to try, and we want to return our test pose, I guess, here. So for now, the continuing to try, or like going further on our path, this result will not be used. We just use the result of the first test, which makes no sense, but is temporary. And if we arrived, we want to return also test pose, because right now we weren't even using the return value, so why not? And test pose here as well, and test pose here. So bytecode makes no real, doesn't have any real meaning right now, and this is a failure. And just for now, let's return 0. Also doesn't make much sense. Okay, still good sounds. Okay, good. So I will return 0, 0, which doesn't make any sense, but just temporary. So right now the goal, okay, good. So when I am in the fountain, no path is even searched because I know I cannot go here. So I should make her not go if I can't go. So if depth is free, so that pathfinding an experiment, I can do it all in the select destination. Ah no, because I want to have the visualization. Okay, so let's say here, let's say we have a variable. We can just set the target. We can just set directly the target here. And if we don't have, if destination is free, we set the target and say that we have a target. So she will attempt to go there. Player has targets, right? If the destination is not free, it's blocked, we don't care. No, okay, no, because if we say player has targets, the player will always move, which is nice actually. Player constantly moving toward the mouse. So maybe we want to wait for the click to happen. This is the click, this is mouse button was just pressed to set that to true. And we can even here check if the player target is equal to 0. So x equals 0, and then we know it's invalid, because if you recall, if we don't find any solution, we return 0 basically. And here we could set the player target. No, that that doesn't work either. Yeah, we should really do the test only when we click, but let's leave it like this. It's okay. So when she stops, that means that player has target is set to false. Or is she inside? Ooh, that's a edge case, I guess. Should increase the number of tests. All right. Oh shit. What did she stop? Why? Ah, she's going too close to the limit, I suppose. And then sometimes with my mouse moving, the test fails. Okay, so it's quite annoying. So maybe I should. Maybe when you click, it sets the target, and instead of using the mouse pose here, we use the target. That makes sense. No, that doesn't make sense. Just want a quick and dirty way to get all right, so we need another variable. That's fine. So or maybe we don't need another variable, we just need to modify this, because here, okay, this is the movement, no, this is the effect, sorry, this is the effect on the ground when you click. This is the movement, player movement, okay. So we go toward player target and we stop when we reach player target. Yeah, okay, let's make a new variable, so player final target. And this one is like kind of intermediary. And when you click, you set the final target. So when you click, you set the final target. And here, you use the final target instead of the current mouse pose. So you will have to click to set. So let's see if that works already. No. Sort of. Yes, it works. Okay, and we just have to wake her up. So now we don't need to click anymore. So yeah, it sets the final target. It tells her that she has a target, but sometimes, okay, so this just needs to go before, of course, the pathfinding code, like that. Right, pretty good. Pretty good. Yeah, it's nice. So maybe we can just up that stop after test count. We can just, the default value, we can put it much higher so she can explore further. Stop after testing. Why do I log this? Wait, okay. Ah, because I track it, okay. I didn't remember that I logged everything that was tracked. That's a bit stupid. Do I need to do a clean build for it to propagate? Perhaps. Okay. Cool, cool stuff. Pretty happy about it. So it doesn't take, oh no. Oh no. Oh yeah, I didn't fix that bug yet. If like she has to go back, she doesn't find okay. So yeah, there is still work to do. Still a lot of improvement possible. But I'm happy to see that just for basic avoidance of obstacles, she manages. That's pretty nice. So to finish off, we'll just remove the visualization of the hits map. Hit call map. Collision map. Here, I can just add the comment visualization of the collision map. And set it to that way I still get compilation errors for that block. And let's do something similar for the pathfinding pathfinding stuff. So we don't want to draw anything. And let's say debug these and debug these is false. Oops. And use that also when we draw lines. So where are the lines? Draw line here. And actually, I guess I could put them both here. Okay. Cool. And now the effect plays at the wrong location. So maybe I can also fix this real quick by going pathfinding, select destination. So this is the effect. So go to effect, and we want to target not the target pose anymore. Player target, not this, but final. I have to rename those variables. They are really bad currently, extremely bad. Yes. And if I click in a wall, it doesn't do anything. Could even remove the effect, perhaps. If I go here, she's stuck. Okay, but at least if there is no. Whoa! What the hell? Oh my god! Okay. Wow. Okay, so not so robust yet. I suppose, yeah, since she does it does the calculation every frame. If we stick to one path and keep it in memory, maybe that's better. I don't know. But of course, yeah, if yeah, not bad. Cool. All right, so that will be it for today. I don't know if I will pick it up at the same stage next time, perhaps, to improve it, to resolve this issue of looking back and finding the way around obstacles that go in opposite directions. But yes, thanks for watching, and see you next time.